Okay, so this question is about gas chromatography. Okay, and it tells us here that chromatography is an important technique used by analytical chemists to separate substances found in mixtures. Gas chromatography can be used to show the number of compounds, the identity of each compound, and how much of each compound is present in a mixture. That's three things we can get from these graphs here. The diagrams below show the gas chromatograms for mixtures 1 and 2. Each mixture contains more than one compound. The compounds in mixtures 1 are labelled A to F. Okay, so we've got these two chromatograms. So across the bottom we've got retention time, which means how long each of these different chemicals stayed in the chromatography tube. Okay, so it's how long it's retained. We've also got the strength of the signal. Okay, so the strength of the signal is the height of the peak, and then we've got a number of different peaks. Okay, so the retention time is characteristic of the chemical. In other words, each of these peaks, however long it takes to come out of the machine and be detected, that tells us the identity of the chemical, if we know what we're looking for, of course. The height of each peak, that tells us how much of those chemicals are present in the mixture. Okay, and so we can use that information to compare these two mixtures here. So the question asks us to use the chromatograms to compare the similarities and differences between mixtures 1 and 2. Okay, so if we look for some similarities first of all, in mixture 1, we've got 1, 2, 3, 4, 5, 6 different chemicals. In mixture 2, we've got 1, 2, 3, 4, 5, 6 chemicals. Okay, so we could say that both mixtures contain 6 chemicals, okay, because there are 6 peaks. We could also say, if we have a look at the retention time for each peak, that gives us the identity of the chemical. We can see that there's a peak at 1 minute here, and there's a peak at 1 minute there. Okay, so we could say that both mixtures contain chemical A, because the peaks appear at 1 second. There's a peak here at 3 seconds, and there's a peak here at 3 seconds as well. So we can say B. Okay, we've got a peak here at 6 seconds, but no peak there at 6 seconds. So those two, this chemical here, C, is not present in mixture 2. There's a peak at 8 seconds, and again, there's a peak at 8 seconds there. If we just double check, there's one at 11. Okay, so the one at 11 is E, so we can have D and E. And there's one at 12, but not one at 12 here. Okay, so both chemicals contain A, B, D, and E. So those are, I think, the similarities. Okay, now the differences are, I could say that mixture 2 contains other chemicals apart from A to F. We can also see that there's different amounts. The ones that are shared, so for example A, in mixture 1 there is 1, 2, 3, 4 units of mixture A. In mixture, of chemical A. In mixture 2 there is 1, 2, 3, 4. Count 1, 2, 3, 4, 5, 6, 7, 8. So there's twice as much of A in mixture 2. Okay, so we can say there are different amounts. Okay, we could go into detail, but we've run out of space here. So different amounts of A, B, D, and E. Okay, so we've got 4 marks here, and we've made 4 different points there. So that should cover most of what's required in that question. And then part B is quite difficult. It says explain in terms of molecules why F has the greatest retention time. Okay, now you need to understand how a gas chromatogram works to answer this question. So you might remember that a gas chromatogram works by placing your mixture, okay, into a stream of what's known as a mobile phase. Okay, that's a chemical that passes through the chromatography machine. And the reason that F is the last one to appear at the machine, at the sensor, sorry, is because it has the least affinities. It doesn't get on with the mobile phase. It doesn't stick to the mobile phase. The mobile phase doesn't carry it well. Okay, and therefore it takes a while for it to get through the machine. Okay, so F has the lowest affinity. Affinity means like something, basically. So lowest affinity for the mobile phase. And so travels slowly through the column. Okay, so in reality, when I say column, I mean a coil of tubing with packed with another chemical known as the stationary phase, but it's called a column. Okay, so it's the lowest affinity.